well. So moving on to what we just mentioned, our R value, our Pearson's correlation coefficient. So this measures the strength of a linear relationship. And also it does tell us about the direction. So instead of, oh, maybe weak, maybe no association, maybe moderate, maybe strong, we actually get that exact precise mathematical number value that tells us about it. And like I said before, we generally assume a linear relationship is present, but in some cases it isn't. And a residual plot is how we can kind of figure that out, so making that connection again. And when we're calculating R values, we usually do use a calculator to do it because it is quite a painful process by hand. But there are little tricks and strategies you can use to kind of speed up that process if you do need to calculate it by hand, but we won't be going into that today, just for the sake of time. Another handy hint that I have for you guys is to get familiar with your formula sheet. I cannot emphasize that enough. It is so important to know what formulas are on your formula sheet. So first, you know which formulas you're going to have access to in the exam. Second of all, so that you know which formulas you're not going to have access to in the exam, so you know you need to memorize. And finally, so that you know like what version or form of the formula you're going to have access to. Because sometimes we can learn a few different formulas, and it's really, really important to know which one you're going to have on your formula sheet so that you can then make the decision like, oh, I actually don't like that version of the formula, so I'm going to memorize this one because I think that'll be most helpful for me. Or you can go, no, I just want to use the formula on the formula sheet. So you need to make sure you know what the variables mean and represent. Because if you don't know what I or R or T in a certain formula represent, then it's not actually a very helpful formula. So the more familiar you are with the formula sheet, the more helpful it will be come exam time. So Pearson's correlation coefficient is a number between -1 and 1. So we talked about before how the sign before it indicates whether it's positive or negative, which is again our direction. So is it a positive or is it a negative? So our negative R values are between 0 and -1. And then our positive R values are between 0 and +1, the opposite. And then the size of the number, so the size of the R value, again tells us about the strength of the association. And this is an example of like a classification system that you could use to help work that out. So for example, the ones that are closer to 0 is what we call like a no association. So as a general rule, the closer it is to -1 or +1, the stronger the relationship, and the closer it is to 0, the weaker the relationship it is. I'm going to illustrate that a bit clearer on our next slide. And again, just to further flag that warning there, we can only calculate R values for linear data sets. Because if it's a non-linear data set, for example, like a parabola or like an exponential curve, then R value isn't helpful because Pearson's correlation coefficients are only for our linear data, which is why it's important to do a residual plot if you're unsure. But to come back to what I was just saying about before, this table actually illustrates it quite well. So you can see that if our R value is kind of hanging around that 0 mark, our points are really loosely associated. There's just no association going on. They're kind of just randomly scattered around. But you can see that the closer we get to 1, the stronger our relationship is getting, and the closer we get to -1, the stronger our relationship is getting, just it's a negative relationship. Whereas the closer we get to +1, the more strong positive relationship it is. So having a bit of a rough kind of guide for like these kind of classifications in the back of your head is super, super, super helpful and important. Because you might be asked to like interpret what does a R value of 0.84 mean, and then from that you can actually interpret that with 0.84 it's positive, so I know it's going to be a positive relationship, and if it's 0.84 I know it's going to be quite strong, so I know that it's going to be strong. And then you can also infer from that that it's going to be a linear relationship, otherwise it wouldn't have been appropriate to calculate an R value in the first place. So you can learn a lot from both scatter plots and R values, no matter which one you have first. This is just like another little helpful guide to help you with like interpreting the R value. If you find that interesting, pause and have a look at that there. And this is one of my favorite handy tricks of all, which is how to actually calculate the Pearson's correlation coefficient using your calculator. So you need a scientific calculator to do this, and it's as simple as following through each of these steps, which again, you can download the slides or take a screenshot if you want to save this for later. So the first thing you do is you press the mode button on your scientific calculator. It might be next to the on button, or it might be somewhere else depending on your calculator. And then it'll bring up some options, and you want to choose, you want to press 2, which will say stat. It'll correspond with the word stat, which is short for statistics. So this is to symbolize that you're putting your calculator into statistics mode. And then you'll press 2, which will say A plus BX, which is referring to bivariate data. You can see we've got our 2 variables there. And then it'll bring up a little table on your calculator screen. And then so you enter your data values. So if, for example, your X value is 5, you'd put 5, enter, and that would add it to your table. You can enter all your X values and all your Y values by putting the number in, then pressing enter. And then also by moving around the little table grid using like the arrow keys on your calculator. So you enter all your data that way, and once you've entered all your data and you've finished, then you press on, and that will actually clear your data off the screen. But don't stress, your calculator has it stored in its memory, it's not gone. And then after that you press shift 1, 5. And 5 will be associated with, it'll say REG, which is short for regression, which is what we're doing. We're doing regression data analysis. And then you press 3, which will correspond with R. And then once you hit enter, that will actually give you your R value. And if anything like this doesn't quite line up along the way, go back, give it another try. And again, remember your R value should always be between -1 and 1, because that's the only possible outcome for an R value. And then this step's really important at the end to put your calculator back into regular mode, so it's not like interfering with your calculations, because like the settings can get a bit weird sometimes. Make sure you again press mode and then 1 to get it back to that regular settings. So coefficient.